Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery that all started with a big bang. Hey!
Once upon a time, there was a point of infinite density and finite time. Then, it began to expand. The universe sufficiently cooled to allow the formation of particles smaller than atoms, which are protons, neutrons and electrons, and eventually, atoms. The giant clouds of these primordial, you might want to read this for a minute, elements are getting closer together, coming closer together, and combining together. Then there's a star. These stars formed the elements in the periodic table, the building blocks of planets, life, and everything. From the start, but more specific, the universe that we live in today started as a very small, hot, infinitely dense point called a singularity that exploded. It gave way for the creation of matter, energy, space, time. You probably know all of that already, so let's dive deeper into the eras of the universe. After the explosion, there were two eras that followed, radiation era and matter era, but let's tackle the former first. This era involves the dominance of radiation, where it is divided into 8 smaller stages, epochs, which are Planck, grand unified, inflationary, electroweak, quark, hadron, lepton and nuclear. The Planck epoch is a time where there is no matter, only the superforces, namely gravity, strong nuclear, weak in electromagnetic energy, up until gravity broke up.
Broke up? Like a band? Like the Beatles?
With the other superforces. Making way for the next epoch, grand unified theory. In this epoch, the strong nuclear broke away from the 3 remaining superforces. Then began the inflationary epoch, where the universe expanded and grew very hot.
Oh, that's hot. That's hot.
The electroweak epoch came next, wherein the weak also split from the superforces. Then came the hadron epoch, a time where it is too hot for subatomic particles to form. But eventually it got cooler for quarks to bind, which was experienced in the quark epoch. The lepton era gave way for a significant change of the proton and neutron particles to diffuse, creating nuclei, and eventually the first element in the universe, helium, in the nuclear epoch. Take note that all these epochs happened in the span of a few seconds to a minute. That's basically all of radiation era. Let's now go into the matter era. First up is the atomic epoch, where the universe cooled down enough to allow electrons to attach to nuclei, forming the second element, hydrogen. In the next epoch, the galactic epoch, the first and second element, helium and hydrogen, scattered over the universe with atomic clouds, which formed the seedlings of galaxies. Atoms in the clouds that connected because of the presence of gravity. From there goes the stellar epoch. Stars form from the elements that arise from hydrogen and helium, which can now be found in Mendeleev's periodic table of elements.